Hi, I'm Nikki Reed, a longtime EMA board member and a pro at EMA Talks. Actually, it's just my second opportunity to host, but I'm very excited because we are diving into one of my favorite subjects, fashion, with someone I'm very excited to speak to. More specifically, we're going to talk about the process of how fashion affects our resources. So today, this is EMA Talks Global Change Awards winners. And what does that mean? I'm going to tell you. I'm going to try to tell you. So EMA Talks is a conversation program at the intersection of arts and sciences where entertainers and creatives chat with experts. I am not the expert today. I am here to entertain and create, I suppose, in all sorts of topics dedicated to saving Mother Earth that I love. In this case, our expert is winner of the Global Change Award, a finalist at the EMA Future Innovator of the Year Challenge, and his technology is bananas. Today's conversation focuses on Dipak Mahato, PhD, founder and CEO of SeaChange Technologies, a company that focuses on delivering economical and sustainable solutions for apparel manufacturing, wastewater management. Say that 10 times. He's a former principal scientist at Pfizer, a tiny little company you may know something about. And now, thanks to a generous grant from H&M Foundation, he's a badass entrepreneur. He was always a badass entrepreneur, now even more badass. Focused on delivering economical and sustainable solutions for apparel manufacturing and wastewater management, something as a fellow entrepreneur in sustainable fashion I cannot wait to discuss further. So welcome, Dipak. Thank you for joining me for this conversation. And you have such an interesting background, so I would love to hear from you on how you got started, what brought you to the space. Very interesting to try to connect the dots between Pfizer transitioning into sustainable apparel wastewater management. So maybe you can take us on that journey with you.
Thank you so much, Nikki. I really appreciate that very flattering introduction. And I don't really know that I'm all that, but I'm, oh, thank you. Making the jump and a little background. Getting into water was something as a business, as a startup, as an entrepreneur, is not something that I had ever imagined. Getting into fashion industry is not something that I had ever imagined. So I'm just kind of, well, let me tell you how I got into this mess. I actually got my PhD in genetics and then worked in biotech and pharmaceuticals for a while, did my postdoc at NIH, studying stem cell biology and male reproductive endocrinology. And that got me into a little biotech company that was then bought by Pfizer, where I worked for over 10 years in various positions, developing diagnostic tools, pharmaceuticals, biopharmaceuticals, and also working in industrial agriculture. And so lots of interesting experiences there. I loved working in Pfizer, just a great, very innovation and very team-oriented environment. That has nothing to do with water or fashion. So the thing that I really carried from there, and one thing that a lot of folks may not know about that company, is that it really has a very strong culture of innovation and entrepreneurship. And what that does is keep us science geeks motivated to focus on and work in a real team-oriented approach to tackle really big problems. And to think outside of our lab bench and our scientific peers, to work with folks that are outward, like in marketing and the business and sales and manufacturing and everything it takes to bring, what we develop at the lab bench to the real world, and solve big problems. And so that is really, that sort of mentality, I think, is what really enabled me to take on, or at least made me think that I could take on these kind of big challenges. And so Pfizer, as a big company, goes through a lot of reorganization and changes every once in a while. And with one change in particular, they wanted to move me, but the position and headquarters moved to Michigan, which I would have been fine with, but that would have been complicated for my family. So I took a package at that time and was thinking about what to do with the next step of my career. And while I was just sitting at home, not really having any science to do, I came up with this idea about a way to purify water. And I kind of knew that water is a big deal. I looked up some information and patents around how this was being done. And the more I looked at it, I realized that not much had really changed in many decades around how water is treated, how it's purified, and that this is kind of a really big problem that could use some innovation. And I kept getting more and more excited about it and talking about it around the house. And my wife said I had to do something about it or shut up. And I was like, oh, I couldn't shut up. So here I am. So I dove in and started trying to figure out how to get it off the ground as a startup.
Wow. It sounds like you were describing kind of a mindset in the beginning, having the ability to think outside the box and maybe take your ideas to a new level, which is interesting because what I was seeing with that is like this interconnectedness between areas that you would think are totally not connected. But when I hear you say like industrial ag and studying, like endocrinology, to me, I see like a direct connection between things that you can learn about industrial ag and the operations and what's used and like the chemicals that are used and the water system, and connect that to biology and science and pharmaceuticals, and then to see that connection back to fashion in a weird way. When I'm listening to you speak, it sounds not as crazy to like connect all those things together. And the fashion industry in particular, I think fashion needs science. I think fashion needs innovation. And so what you've done is you've brought a really unique perspective to the fashion industry because of that. So I think it's really incredible. And I just would love to hear you talk about, you've landed in the fashion space, but I want to hear you talk about what that transition is like now that you're in that space, focusing on how to bring innovation specifically to an industry that really needs it.
Wow, I think that really everything is connected. I love science. Since being a kid, I've always loved trying to figure out how things work. I think that there really is only one set of rules that governs how things work.
Yeah.
And the different sciences that we have, whether it's biology or chemistry or physics or mathematics, are just different languages to try to explain the same phenomenon. And whether the application is in biology and agriculture or medicine or engineering.
Yeah.
We just bring the knowledge that we have and the experience that we have and the tools that we have to try to understand things and if we're an entrepreneur, we try to solve problems and create, economic growth and solutions. So the perspective of innovation, I think often in any industry, I think people get used to doing things a certain way. And
right, you get comfortable in your routine.
Absolutely. And it's more than that. It's just there's sort of this fear of doing things differently or questioning why things are done the way they are.
Yeah.
And I learned this a lot from design thinking and design research, just trying to look at situations and problems kind of like a child, and just asking why things are done the way they are.
Yeah.
And and if you're not afraid to ask the dumb questions, um, sometimes you can discover some kind of neat opportunities. And there are opportunities for innovation everywhere. Everywhere. There we can do just pretty much not anything I can think of that we can't do better. And so now fashion is a little that was a whole new industry for me to get into. And when I started out with trying to develop this idea, fashion was not it was not my focus. And that, actually finding a focus was really pretty difficult, one that could stick and one that I could get traction in as a startup. When it was actually from industrial agriculture that I had really that first awareness about how big an issue water was, because when I was working with these big ag companies, that was the thing that kept them up at night. When I was in Pfizer, that's not anything that we worked on directly, but that just sort of planted the seed in my head.
You're talking about wasting water or water purification?
Both. They're both very closely related. And
I want to talk about
and they're both big problems for pretty much every industry. I can't think of an industry that doesn't use water, or if it's a manufacturing industry that doesn't generate wastewater when it comes out the end. Or, for agriculture, it's the same, especially animal agriculture is very water intensive and generates a lot of wastewater, which we're familiar with, especially here in North Carolina, where we have more pigs than people. And water and energy are very closely related and tied to every industry. And solutions to address them and improve sustainability really need to take both into consideration.
Yeah, so I work in a parallel space. I work in jewelry, and one of the first things I learned about and tried to pursue after learning about water waste was seeking out a manufacturing facility that had a more conscious approach to water waste. So I work with a factory that has a gray water system, because jewelry is heated and cooled all day long. That's how you heat metal, and then you cool metal, and that's how you form it and shape it. And so there's a tremendous amount of waste. And it's one of the reasons I was so excited to talk to you, to sort of learn more about this and better ways to produce and hear about your technology. So tell me about SeaChange, and tell me about what it's like to, I guess start over in a sense, shift careers, take knowledge from one area, pour it into another, and, be an entrepreneur, start something from the ground up in a space that you were, relatively unfamiliar with, even though you were bringing your familiar technology.
I gotta say that it's probably the hardest thing that I've ever done.
And that every entrepreneur ever.
And I think that I've been really lucky to have a pretty strong community around here, and really globally, that supports entrepreneurship, and amazing advisors and coaches and supporters. And I wish that I had listened to them more. And one of the first things that one of my advisors told me is it's going to take you about 10,000 hours or about 5 years to really make any headway at all. And I just was like, I know what I'm doing. I got this, no problem. And that was completely ridiculous. And so he was absolutely right. And if I had known then what I know now, and how much time it would have taken, and how many failures it took, and how much money we were going to sink into this, I might have thought twice about doing it. But we did it. So, but it definitely was not easy. I started out just with this. The idea was pretty simple, was misleadingly simple, just that we could take any water with any level of contaminant, mechanically spray it into a fine mist or an aerosol. And then when we do that, that we could then we could move that aerosol or the mist in a stream of air. And then while it's moving in that air, the water would evaporate, and what would be left, the contaminants would be left behind as dust. And then we could move that stream of water vapor and dust. When we do that, it just sort of changes that water cleaning problem, which is very difficult, into a much more manageable air cleaning problem. Because then we could just separate the water vapor from the dust and then be done. And so that was a pretty simple idea. It took me a few years to figure out how to do that on a really economical scale, but I've got a couple of samples here that I could show you. It's kind of neat. So this one's actually some apparel wastewater.
Oh, wow.
It's really, this is from.
It's really clean.
This is sludge.
Drinkable.
It's from, from a polyester dye house. And one step, so it's really pretty nasty stuff to clean up. And the thing is that conventional water treatment technologies can't really touch this stuff or do it they do use them, but the problem is that the byproduct, a lot of the dyes and the microplastics are just not biodegradable, and conventional water treatment technologies are biological. They're based on stuff that was developed to either produce drinking water or get rid of sewage, or stuff that's really just biodegradable. Mm-hmm. But the chemicals that are used for dyeing and polyester manufacture are just completely resistant. And so they end up producing kind of this toxic sludge, which is still an environmentally damaging and expensive stuff to get rid of.
And that sludge just goes into the ground or into other water pathways and makes its way back into our bodies anyway, right? Is that the idea? Is that we think we're separating contaminated water, but then we're just basically relocating it?
Yeah, the contaminants still exist is the problem.
Right.
And depending on where the manufacturing site is, the regulations may be better or worse, or not as good. And so some places do really well, and they contain sludge and regulate it very tightly. Other places, not so much.
So forgive the silly question, but I'm always a fan of asking dumb questions if it leads.
Those are the best. There's no such thing.
So it sounds like what you're doing is kind of mirroring nature in a sense, because am I wrong to think that sounds a lot like how we end up with cleaner rainwater, right? I mean, water evaporates and then it's probably in some type of like fine mist or small particle, and then it's separated in the air due to weight, right? I mean, is it kind of the same thing? Obviously a lot better.
There's similar principles, and nature needs a little help sometimes, especially when the stuff is non-biodegradable. Then we need to give it a little boost. And so there are some additional tricks that we use. Before we spray it into an aerosol, we pressurize that water to about 3,000 psi, and then heat it to a temperature that's called subcritical, where it starts to actually ionize. So it breaks apart into a hydrogen and a hydroxyl radical. And when that happens under high temperature and pressure, the water, that ionized water itself, will then break down the organic contaminants, all those plastic microfibers, the dyes, fluorinated compounds that are really very, very, very difficult to break down. Under those conditions, we can destroy those completely. So the contaminant is actually gone before we actually create the aerosol.
The contaminant is gone due to heat?
It's called an advanced oxidative process. So we oxidize them.
Okay, so you're not even worrying about disposing. That was my next question. You're not even disposing of the contaminants. No, you're making them disappear.
Yeah, disappear is a little strong. We destroy them. So they're just oxidized and gone.
Right, disappear is not sciencey. I know, that was like a little magic.
Sorry, it's my geeky self here.
Don't go hand in hand. Okay, but I get the gist of it. So Are you creating, so it's purification and focusing on water waste. So you're creating water that's drinkable?
Oh, good question. So as I was developing the prototypes, actually the first market that we were trying to break into was desalination or drinking water production. Mm-hmm. And in that prototype, I did take the water vapor and turn it back into, or condense it back into water. And it was amazing, distilled quality water. And that, as a startup, I was so excited about that, but nobody wanted it. Water is just such a funny business that anyone who's paying money for water or needs or desalination, like in the US, that's kind of big municipal or industrial applications, they do not want to try anything new. It is a very risk averse industry. And so I just got absolutely nowhere. And anyone in the world who really does need it doesn't have any money, and I didn't have any money. And so it just went nowhere. And so I realized that to get this thing off the ground, I'd have to try to find another approach. And that's when we started focusing on wastewater from industrial applications. In those applications, they need a solution, but the nature of their problems are usually kind of different in that those industries are usually in areas where there's a lot of fresh water and it's really cheap. And so for that application, we just kind of focused on the decontamination and eliminating the sludge component. And then we just release clean water vapor to atmosphere. And so that's kind of where we are right now, just because that's what the market, that's what we need to do to get off the ground. But I do hope with our next, and we actually just got some funding where we're going to start investing in this soon, which I'd love to tell you about. But I hope soon that we can focus back on recovering water and energy.
Sure. It seems like it would be not only a natural segue, but one would benefit the other. Seems like it's two aspects of the same, or two halves of the same whole, you know? So you are obviously really special to all of us at EMA because you're a finalist. So that's already just massively impressive. And you were a finalist in the Innovator of the Year competition in 2019. So how did that lead to the Global Change Award? Tell us.
Being a part of that, of the Innovator of the Year award competition was an amazing opportunity. And I was just I just felt so lucky to be there and have that opportunity to go, especially because it was combined with the EMA Impact Summit. And so being able to meet leaders and scientists and artists and folks from government and industry and everywhere that were all interested in understanding and figuring out what they could do to create a green economy was just amazing. And to be a part of that. And I absolutely love that. And it was such a crazy time because we were just finishing a pilot trial in India. So I went straight from there to the Impact Summit. And it was just a whirlwind. And so it was amazing. It was a very exciting time. But to get to the GCA thing, so I had already kind of been focusing for a while on fashion and especially with the trials we were doing. And I was aware of the H&M Foundation and the Global Change Award and just kind of wondering if we had what it would take and if we had a chance. I mean, all the other winners were so amazing in what they were trying to do. And so I got up there at the Impact Summit and pitched, and then I watched Malin interview in her panel discussion. She had Eric Bang and Deanna Meany, and it was just so amazing. But then I had the opportunity to meet them, and they saw me pitch, and they were very complimentary and invited me to apply. And so I kind of think that might have had something to do with it. I don't know, but it was. It probably had something to do with it. It was awesome.
That's okay. Whatever helps, right?
Yeah,
I
absolutely.
don't mean to go rogue again, but can you tell me what's behind you? I'm just fascinated because it looks like
This,
something I can't pronounce and wouldn't know what to do with.
this is SeaChange Technologies. This is my humble warehouse and workshop in downtown Durham. And this is our prototype system. This is the latest version of the SeaChange machine. And what it does is it takes this really nasty wastewater and in one step going through here, reduces it to pure mineral solids, which can be reused. So
wait, the mineral solids can be reused?
Yeah, so I didn't tell you about the whole process because I don't know how I don't know how much I don't know how much. Let me tell you, there's basically two. The way that I look at contaminated water is that there's kind of two kind of big groups or types of contaminants. Obviously, there's all kind of contaminants, but I look at them as either organic, which is kind of carbon based, or inorganic, which is like salts and minerals. The organic stuff, when it comes to textiles and fashion, is going to be things like fibers, microplastics, dyes, organic acids, detergents, and probably lubricants, other stuff like that. Anything that's sort of carbon or petroleum, petrochemical based, or fiber, or something like that.
None of those things I would have ever associated with the word organic, by the way. So I'm so grateful for the lesson.
You know, it means different. Okay, so it's my science geek part coming out. Okay, I know organic means something different to a lot of people, and they want to eat like, you know, especially if you talk about
I've never heard anyone say like organic microplastics ever. Never heard that sentence.
And yeah, I need to come up with a language that's probably going to work better for everyone. But that's what I meant. It's kind of hydrocarbon based. Okay. All right. So there's those classes of contaminants, and then there's the salts, minerals, and metals.
Inorganic salts and minerals. Okay.
Yeah. Okay, so what I was explaining to before, how the process works, the first thing we do is we heat and pressurize the water to the point where it ionizes and destroy the organic components, or the hydrocarbon components. So all the microplastics, the dyes, and the fibers get destroyed. Then all that's left is the water and the salts and minerals. And so when we put when we burst that water into an aerosol or a mist, and then move that through the airstream, then we actually recover those salts and minerals. And so that's what makes the fine white powder.
But they're chemical free, so they can be used, or?
It sort of depends on what the application is. And we've treated a lot of different wastewaters. And so in the case of textile or apparel manufacturer, it sort of depends on what stage or process or fabric we're working on. And so with polyester, like the trial we did in Taiwan, we were at a polyester dye house. They add no salts or minerals. It's a completely hydrocarbon or organic kind of process. And so there's almost nothing left. There's no salt or mineral left. The only salt that comes through is what was originally in their groundwater, which is pretty clean. And so there's nothing there. In the case of cotton or denim dyeing, they use reactive dyes that only bind when you have a very high salt concentration, and they use ammonium sulfate. Actually, I have one of those. Just a second.
This is fascinating.
Here's some salts that we got from our trial in India. But anyway,
wow.
They use this when we process their wastewater. It's nearly saturated, so it contains about, which means there's a really high concentration, about 1 to 2 pounds of this stuff per gallon of water that they need to use in their dyeing process. So when we're done, we just give this back to them, and they can put it back in the front end of their process. And so we recycle that on site. So it just sort of depends on which application we're going in, the kind of byproduct and how it could be recovered and reused.
So tell me about scalability and volume really quickly, and how much water you feel you can recycle, or in one session, let's say, what that process looks like, because we all know that the fashion industry is one of the most wasteful and creates some of the most environmental degradation on the planet. So it takes real scalability and volume, to be able to make a dent in this. So I'm just curious, how much at a time, how quickly, how efficient, like what is this process like? Because the tank behind you looks, it's large, but if we're talking about like huge industrial setups, I'm just curious how many tanks.
This is tiny compared to what's out there in the field, and for what it and for what it does. And I'll tell you about the scale and kind of the capabilities of what we do. Not really anything else out there like it. This machine, it's only about 15 feet long, maybe 16, and about this high. And will process about 10 tons or 10,000 liters of wastewater or sludge per day.
That machine does?
Yep.
Oh, wow.
And so
now we're talking.
And so it's for what it's quite a machine. The thing that really gives it the power that it needs to do that is this thing right here, which we had to design and create, which is actually a little jet engine. And so what I realized when we were developing that is that when we create that mist or the aerosol that we need to flow in a stream of air, what I realized is if we're going to process at industrial scale, which is tons per day of water, that we need to actually move tons of air, which is a lot of air. And the only way to efficiently do that is with a jet engine. And so that was another challenge that I had to figure out. But we figured it out. So that's a lot. But that's what gives us the ability to move tons of water through this evaporation chamber once we turn it into an aerosol. And so in terms of scale, the typical textile factory now, we have ideas of how we're going to change this, but what the industry where we're getting into now, a typical factory will generate, there's variance there, but between 3 to 10 tons of wastewater per day. So that might be 1 to 3 of these systems and they're small enough that they're kind of designed to be small, mobile, and to fit into existing factory operations. And so we see this as sort of a system that we can use to upgrade existing textile factories.
Can you just say that number again? How many tons of water per day does the average textile, just say the number?
They're between, well, let's see, the factory that we did in Taiwan was 3,000 tons per day.
Oof.
Of wastewater, right? It's a lot. These are massive. And if you go to openapparelregistry.org, it's a great interactive system, and it has a great map and shows the location of factory and suppliers and different things all over the world. There are tens of thousands of these sites operating 24/7. And so that's where the numbers really get sort of mind-boggling into how big of an issue this is, and why folks say things like textile and apparel manufacturers responsible for 20% of global water pollution or global industrial water pollution, is because the volumes are just absolutely staggering.
And the last, let's say, 2 decades have really contributed to that, because we've seen fast fashion skyrocket, and the need for more and disposable and cheaper and seasonal trends, and we're not taking care of the sort of unintended consequences of that. And part of why I love this partnership so much between you and H&M is because I love seeing a good example of mainstream and attainable and familiar, like H&M is. I love seeing an example of mainstream, creating effective change from the inside out and supporting industries or innovators or entrepreneurs like you to be a part of a solution, as opposed to collapsing an industry, which is definitely not going to happen. And we're creating effective change from the inside out and being solution based, and targeting, supporting, and financially fueling these solutions. So I love this combination. I love seeing, it's one thing if there are tons of very conscious, sustainable small businesses that are popping up. And that's so amazing. It's amazing to see people, from the ground up building a business that tackles our need for fashion and consumerism, building that into their infrastructure in a cleaner way. That's amazing, these small businesses. But it's also amazing to see larger businesses, shifting operations. I love seeing people work together in that way to create that kind of immediate shift. And I think that you're incredible. And I can't wait to see this water purification water.
I think that those are, I appreciate that. And I think that those are interesting points. I think that the problems of the industry are big enough that it's going to take all kind of different solutions and technologies and people and everything coming together to even make a dent and to kind of shift the economy and the expectations and the behaviors and how things are done. Yeah. It's really great having a company like H&M or the foundation or Adidas or these big players behind us, because that helps us to keep things going. Yeah. But I think that the small companies you mentioned and that approach is probably what really got things started. What really built the awareness among people and consumers about what's happening and kind of the impact of their choices. Yeah. And just the awareness, because ultimately that's what is going to drive these companies to change their behavior. And it's driving it in a big way. The sustainability and being able to manufacture in a sustainable fashion is really driving these big companies to find a better way and pursue the ultimate goal, which is circularity, so that at the end, we can manufacture things in as clean a way as we can. But if it ends up in the landfill at the end of the day, it's awful, because all of that energy and resource and manufacturing and material is just, is going to waste. Circularity is the ultimate. And so there's a lot of innovators that are also focused on creating, kind of recreating that cycle, going from linear to circular.
I have and
we are too.
I have a new task for your brilliant brain, which is I want you to build one of those that focuses on carbon sequestration.
Oh, yes, I love that idea. We actually do pretty good with carbon.
Really?
We don't sequester it, but one of the things that I had to do when we were running these pilot trials, and this was really, really, really challenging, is figure out how to describe our environmental impact. And we've talked a little bit about effluent and how much wastewater comes out of these factories and what's in that sludge and the chemicals that are, I know what's in the sludge. But when I wrote these up in the reports for the brands, it was a little tricky, because they don't, chemical discharge was, oh geez. It's something that it's a little tricky to talk about. But greenhouse gas emissions, for one reason or another, carbon, everyone's all interested in and willing to talk about reducing their carbon footprint. And so what we did is we tried to figure out, well, how much energy and what's the carbon footprint of normal wastewater treatment and sludge disposal. And we actually do really well. We can save this, like a single unit, by keeping sludge out of the landfills, can offer about 3,000, try to remember the number. Yeah, it was about a reduction of about 3,000 tons of carbon emissions per year.
Wow. And is that because, again, I love dumb questions. When you keep the sludge out of landfills, is that because the landfills are then able to sequester carbon?
The landfills, when you put organic or carbon-based material into a landfill, what happens is it undergoes anaerobic degradation and turns into methane, which is one of the worst greenhouse gas. It's one of the worst greenhouse gas issues. And so by keeping that sludge out of the landfill and destroying those organic contaminants, we can prevent that impact.
Right. You're not pulling carbon down. You're preventing. I see. Yeah. It's preventative. Preventative is great, by the way, as opposed to reactive. So that's amazing and wonderful. Are there any plans to talk about energy efficiency within this beautiful contraption behind you?
Oh yeah, absolutely. So it does use energy. There's kind of no way around that. And with this first iteration of the technology, kind of one of the biggest I mean, it takes a fair amount of energy to run the turbine, but it actually takes less energy to operate this than a conventional wastewater treatment system. And the reason for that is because the way that our technology works, when we do that first stage of destroying the organic material, we're actually using that material as fuel to power our process. So the more contaminated the water and the sludge is, the less energy it takes for us to process it with this machine.
Wow.
And for our next generation, we're actually going to use the energy from our turbine to generate electricity. So this unit that processes the 10 tons per day will actually generate 65 kilowatts, which we can give straight back into the factory and further reduce their energy requirement, carbon footprint, and improve their energy efficiency. So really, that's kind of my vision, is to offer a comprehensive water and energy solution.
I love this so much. I love the idea of circular. I think we both agree that the only way forward is to actually reuse and repurpose. We can create new things that are better all day long, but the real path forward is circular economy and circular in everything we do, especially fashion, because it's such a huge contributor to a lot of the problems that we have. And, I don't know that people are really aware of the fact that, we were just talking a minute ago about the intersection between science, health, wellness, ag, and fashion. And fashion is a major contributor to a lot of the other things we're facing, like, the disease and cancers and endocrine disruptors and environmental pollution, and all of the things that we think aren't connected generally are, especially when it comes to our health and wellness and how we produce. So I think consumer awareness is the biggest thing. And I love that you touched on a second ago that carbon is such a hot topic, and that I'm definitely putting words in your mouth, but it's a little sad that talking about chemicals from all that wastewater is not commonly talked about, or also an exciting topic for people. And I think we need to change that. And I think the way we do that is, we talk about it, we get loud about it, we connect the dots with it, because there's no reason why carbon should be a more important topic than all of the chemicals that are leaching into our soil and our drinking water and our oceans and our bodies from all of this, and your technology is really amazing because it's finding a solution, not just for water, but for those chemicals.
Yeah, I think so. But it is super difficult to talk about. And that's what's so great about working with EMA. So y'all can help me with that.
I've got you. I'm there for it. I'll talk about chemicals with you all day long. Great. So what is your, I guess, vision of a sustainable future? What's your vision? What's your vision for SeaChange? What's your like 2 to 5 year plan? And what does a sustainable future look like to you?
We got a lot of work to do.
Mm-hmm.
And I think that, you know, the fashion industry is gigantic.
Mm-hmm.
I mean, we're talking about $1 trillion global industry that you know, it's cranking out products throughout this global supply chain, and so addressing that is certainly significant, but it's one of many industries, and so, you know, everything from energy production, food production, you know, transportation, IT, everything, you know, uses water and energy and affects our climate. And to have a truly sustainable future, all of those need to be addressed. I think the neat thing about fashion is that because of the way that the industry is structured, with kind of these big brands on top, and those brands, they need to be responsive to what people want and how people want to present themselves, and 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 people choose fashion to express themselves, to show what's important to them and reflect their values and their choices, and so much more. And so the brands need to be responsive to that. So as people, you know, try to, you know, as sustainability becomes more important and people understand the consequences of their choices, the brands need to reflect that with what they do and what they offer. So it's a neat way to kind of move a big industry. And
Yeah.
and so it's a neat way to get started. At least it has been for us. And I think that, you know, the problems are big enough that I don't think you know, I hope that SeaChange can have a big impact. If nothing else, I hope that we can at least have a little impact or inspire more entrepreneurs to get involved and start getting more solutions in here. But ultimately, we need to save the planet. We need to save our climate. We need to reduce carbon emissions by gigatons per year. We need to create a manufacturing process that's sustainable and doesn't impact future generations. And so I hope that we can be a part of that.
I think you already are. What do you wish, if you could pick one thing, what do you wish technology-wise already existed in the sustainable fashion space?
It's hard to say. I think that if we could do things over again, which we can't, not really. But if we could do things over again, creating the fashion industry from the ground up as a circular model, as a cradle to cradle kind of technology or system, that would be amazing. If we can at least create that in sort of a microcosm, that would be a start, just to show that it's possible.
Sure.
And we're actually doing that. So we talked a little bit about wastewater from dyeing and finishing, which is what we're focused on, you know, and putting these machines into existing textile factories to kind of clean them up. But the idea of circularity involves taking post-consumer used clothing and figuring out a way to get that material back into the front end of the supply chain where we can use it again. And that is also a very water and energy intensive process. And so for our latest project, which we just found out like a week ago that we got funding from Department of Energy. We're collaborating with a company called Circ, which is based right up in Virginia, that's focused on recovering polyester from clothes at the end of their life and making virgin polyester out of it again. And so we'll be working with them to make that a zero waste process.
Wow. That's very, very cool. I mean, when you say it, it makes total sense, but I was on the journey with you while you were talking about new manufacturing that I didn't even think about the fact that you can have such a huge impact on that whole kind of reusable, renewable, repurposing section of this industry too, which is massive, because I guess at the end of the day, if we're reusing and repurposing but still depleting, all of our natural resources, even though we're not creating new product, we're still depleting, then it kind of, in a sense, still sets us back, So it's amazing that you can come in for the slam dunk at the end to create a zero waste process in a well-intentioned industry, That's amazing.
We hope so. There's opportunities for innovation everywhere.
Yeah, so. Everywhere. It's true. And the thing about, sustainability, at least for me, is that I feel like we're always finding newer and better ways to even to produce, even if it's conscious production, there are always better ways with technology. So leaving space and room in your business to kind of grow into those areas and not cement yourself into a way of producing that doesn't allow you to break from that model, I think is a really important part of, at least when I talk to, entrepreneurs that want to ask about, if I have any, little nuggets of wisdom from trial and error with, running my company. I always say that, it's important to not cement yourself into one area. And now as we move through sustainability and into regenerative fashion in that space, I think you'll have a huge impact there as well, because regenerative fashion really connects, agriculture to fashion in a way that I think people haven't before, how we can use the cotton that's grown to produce this type of apparel, how we can use that cotton and that healthy soil to create that whole cyclical nature, I think is really cool and amazing. And you coming into that industry will be very interesting too.
We're very excited about that. Definitely.
Yeah, I'm very excited too. This is wonderful. I'm like so inspired. I didn't even look at my cheat sheet here. I probably didn't ask a single question that Emma wanted me to, but I just had so many things I wanted to talk about.
Well, I appreciate it. It's just been so much fun to talk about these, and I really appreciate your enthusiasm and the experience that you've had with your businesses as well. It's I'm sure it's been a challenge for you as well. It's so challenging. Every company, I think, is just so unique. There's just not really a formula that you can follow or a roadmap to do something that's never been done before. It's just, you just kind of gotta fail and fail and fail, and hopefully at some point not fail.
And hopefully create things that can have a global impact, That's why
absolutely.
It's so impressive, because in just a short amount of time, it's only been a few years, right?
Yeah, let's see. I had the idea in about 2014, and I think really focused full time in 2015. So yeah, it's been a few years.
Yeah, in a short amount of time. That's also a long amount of time, depending on where you're. I see both sides of that coin, definitely. But if you just take a step back and look at where we're at, timeline, not in your mind, but just in this age-old industry, that's a very short amount of time to have such a huge impact on this space. So I think it's really wildly impressive, and I hope you give yourself the credit that you deserve for that.
Thank
because
you.
you're doing really impressive things. And I also want to talk about, we can talk about it here, or we can talk about it offline later. I want to find a way to make this type of subject, wastewater wastewater management. I want to find a way to take those words and make those keywords digestible for people. Interesting for mainstream. I mean, that's what we're noticing, right? Is that when mainstream attaches themselves to the outcome of the thing that you're providing or the solution that you're creating, when they attach themselves to the glory of that solution, and they want to be a part of that, I think that type of attachment is where we really see culture move forward, you know? So I want to brainstorm ways to do that together. And I know that that's what Emma is all about, which is so amazing, taking people from all walks of life and different brains and different backgrounds and different skill sets, and kind of creating this, like, you know, crock pot soup, if you will, of all these amazing, colorful things. And I think that there's a space to do that with wastewater management, you know?
Oh my goodness, Nikki, I would so very much appreciate that. We have get everything we do is difficult, but figuring out how to talk about wastewater, sludge, and all these chemicals in a way that doesn't actually frighten people and turn them off, but is actually engaging is really, really difficult. And so we definitely need help.
I think we talk about it, and I think we create visuals for it. And I think, I was a part of a series a few years ago called The Years of Living Dangerously. And everybody who was a part of the series had a topic that they had to make, quote unquote, sexy and cool. And my topic was carbon pricing. And I was like, oh man, this is going to be a tough one to make, cool and interesting for millennials and Gen Z, and like they are the future. And so how do we do that? And I think it takes constant reminders to the general public about the importance of this, but in a way that makes it fun and interesting and cool, and really awesome visuals help with that. And maybe Emma can set up something where, like, if we can be in close proximity at some point in the near future, even though we're in a pandemic, shooting some content around what you've developed, and just making it relatable, kind of like opening the door for people to really see the importance of this. Because it really is one of the most needed forms of technology, I think, not just in the fashion space, but beyond, It's funny because there is an awareness around water waste a little bit. Like, there's been a ton of campaigning around, well, let me take that back. I hope there was a ton of campaigning around water waste, especially during this pandemic, because there's been a lot of wash your fruits and vegetables, wash your hands, wash everything that comes into your house. And, hopefully that gave people a little bit of awareness about how important it is to not just leave their sinks running, and to be conscious of that. There's a little bit of that, like turning off the shower, turning off the water when you're brushing your teeth. But I don't think that people realize, like, on a global scale, the level of water waste. And if they did, and if they saw how that affected, we're seeing, like, we're connected to water, right? We're seeing the polar ice caps melting, and we feel things when we see these huge icebergs dropping into the sea with global warming. And we see, we're connected to something in that space, but I don't think we're connecting the dots between the things that we consume on a daily basis. And I don't mean food, I mean consumer-driven business, and the amount of water that's wasted. I mean, I was totally shocked until I was in deep discussions with my factory about this, because, like I said, I produce jewelry, and so much water waste. And I was totally shocked when I went in. I mean, you know me well enough now from this hour-long conversation to know that I don't just, like, skim the surface. I'm the person who wants to go through every single level of everything in my factory, production-wise. And so, I wanted to see, like, how much water goes into producing these tiny little pieces of jewelry. And it's just tremendous. I mean,
yeah,
huge amounts of, and I'm talking on my level, small scale production, I'm producing small, slow batch fashion, so anyway.
Well, I think that's important. And I think that, you know, for any successful business, the owner or manager needs to take that deep dive and to have an understanding of what's going on, so that otherwise you can't be responsible for what's coming out the end or what's coming in, and everything that's happening. And so that's really important. And I think that you raise an interesting point about the economies of scale. And I think that one thing that has sort of driven not only the fashion industry, but others to these kind of mega factories in less regulated areas is the idea that water and energy can, which are usually some of the biggest costs that go into manufacturing, are more efficient at larger scales, are more efficient to manage. Like with a giant wastewater treatment factory that costs like $10 million, you can handle, you know, a lot more manufacturing than if you have to build, you know, a smaller wastewater treatment factory that still costs, you know, millions of dollars. And I think that one thing that I really hope to open up is the idea that you don't have to treat water at scale. And so maybe we can do smaller scale, decentralized, local manufacturing with like one of these units that can handle all of the wastewater from, you know, a small manufacturing facility, whether it's jewelry or clothing or electronics or whatever, that you don't have to have that mega factory sort of scale to have an effective and cost-effective manufacturing.
Or setting it up within a community, you know, I mean, it would be so cool to have, communities sharing this type of system and reusing. I think there's one, not quite like this, but the concept of this, a community I was researching maybe in Denmark that does that. I'm not surprised. But yeah, I mean, it would be really amazing to have like one of these per, let's say 40 homes or something in communities.
Yep. So many different ways.
It's amazing. Well, thank you so much. Is there anything else that you want to share or talk about? Any future plans? Anything we didn't touch on?
You know, I really enjoyed our conversation. Thank you so much. And I guess I just wanted to leave with just one thought, which is that we do not have to sacrifice our planet to produce the products that people want. But to get there, we need to do something really revolutionary, like a sea change. Thank you.
I love that. Thank you so much. I see that and I believe that.